Today we're going to explore the Star Schema modeling technique, which is essential for creating efficient and powerful data models in Power BI. Think of the Star Schema as the foundation of your reports, so much like a strong foundation for a house. While it's not mandatory, deviating from this structure can lead to more complex and error-prone DEX calculations. So understanding this will save you from many headaches and ensure your data analysis is both accurate and efficient. The Star Schema is a specific type of database schema used in data warehousing and business intelligence. A database schema is essentially the structure or blueprint of how data is organized in a database. The Star Schema is designed to optimize querying and reporting, making it suitable for analytical applications like Power BI. The Star Schema organizes data into two types of tables. We have the fact tables and the dimension tables. The fact tables. This is the central table in the schema, containing quantitative data, metrics or measures that you want to analyze. So these are the facts generated by a business process, such as sales transactions. Dimension tables. So these tables surround the fact table and contain descriptive attributes related to the facts, such as time, product details, or customer information. So they provide the context to the data in the fact table. It's important to note that the fact and dimension tables are not technical properties that we set in Power BI or any other tool. Instead, they are identified as such depending on the data they contain and the role in the schema. The fact table holds the measurable, quantitative data, while dimension tables hold the descriptive data. Now let's break down the steps to design a Star Schema. So there are four main steps that you can go through. Firstly, identify the fact table. So we already know that the fact table contains the quantitative data or metrics that we want to analyze. For example, our sales transactions. Secondly, determine the grain of data. So the grain defines the level of detail or granularity of the data in your fact table. Okay, so for example, in our sales transaction, the grain could be each individual sale or transaction. Thirdly, identify the measures or indicators. So measures are the numerical data that you'll want to analyze, such as the sales amount, quantity sold, or profit. And last but not the least, identify the dimensions. And as we already learned, the dimensions provide the descriptive context for the measures in the fact table. We can also identify the measures by nouns, as they represent entities or objects in the business process. So some common dimensions include the date, the product, customer, store. So where exactly in the Power BI workflow can we apply the Star Schema? Well, as you know, in Power BI Desktop, you get your data, you transform your data, and then the third step in the Power BI workflow process is you model your data. So it's in this stage here that you apply the Star Schema once you've identified your fact and dimension tables and the measures and the grain of the data as we just discussed. And going over to Power BI Desktop, under the model view, that's where you apply the Star Schema. Okay, now let's look at a practical example of how we can design a Star Schema model. So here we have sales data for a company that sells furniture, office supplies, and technology products. This data provides detailed information about each order, including order details, shipping details, customer information, and product sales. Okay, so the first step is to identify the fact table. We know from what we've learned that the fact table contains the quantitative data that we want to analyze. So in our example, the quantitative data that we're interested in is the sales amount. Okay, so this entire data set here, this table here, is our fact table. Next up, we want to determine the grain of the data. And remember, the grain defines the level of detail of the data in your fact table. And it answers the question, what does a single row in the fact table represent? So looking closely at this data, we can see that one row represents the sale of a unique product per order ID. So for example, for this order ID here, for the same order ID, we had 2 products being sold. So moving on, the next step is to identify the measures. So that's simple. We've already identified the sales amount as the quantitative data in our fact table, so that automatically becomes our measure. Okay, so depending on the analysis that we'd like to do, another possible measure could be the number of orders. So in this case here, we may count the distinct number of orders, because we know that the grain of the data is one unique row for each product sold per order. So we may count the distinct number of orders. And the third possible measure could be the total number of transactions. So to do that, we could just do a count of the number of rows, because one row represents the sale of a unique product. Okay, so last but not the least, let's identify the dimensions. Okay, so firstly, let's start with the date dimensions. So in every star schema model, we'll always have a date dimension. So looking at our data set here, we've got two date columns. We've got the order date and the ship date. So depending on what you want to analyze by, if you want to analyze by the order date, then you create a date dimension for the order date column. Or if you want to analyze by the ship date, you do likewise, a date dimension for the ship date column. But if you want to analyze, if you want to have the flexibility to analyze both by order date and by the ship date, you can create two separate date dimensions for each column. Okay, moving on, we've also got the ship mode. We know that the dimension is the description, the descriptive attributes about our fact tables. We can also identify the dimensions by the nouns. So the ship mode is also a possible dimension. Next up, we've got the customer details. So here we've got the customer ID, customer name. So that's automatically a dimension. What's this one here? The segment. The segment is also another dimension. We've got the country, city, the state, and the postal code, and the region. So all this information here relates to the customer. So that's the demographics of the customer. And finally, we have the product ID, category, subcategory, and product name. So all these columns here can come under the product dimension. So before we wrap up, I'd like to just make a quick mention that for the sake of this exercise to identify the fact and the dimension tables, we have this data set here that contains all the details, right? So in a real-world application, for example, we might not have the customer name, segment details, and the postal code and all that, right? So this information will not be in our sales data. We will only have, for example, the customer ID. Okay, so let me just put that in green. So all the details that we possibly have in a real-world application might be the row ID and the shipment ID, the date and all that. Maybe the shipment code, it depends. Okay, let's just say that we have that data. And also let me just put this one in yellow because that's the customer detail. Okay, and likewise for the product details. Right, so in a real-world application for sales data, we'll not have the details of the product. Okay, we'll just have the product ID. So let me just put that in yellow, and all those details that are in green are the ones that normally in a sales transaction system, these are the only information that we'll have, right? But for the sake of this for this demo and for this exercise, this data set contains this information for us to sort of go through to identify the dimensions. Well, thank you so much for watching. I hope you got some value in this video. If so, please consider supporting the channel by liking, sharing, and subscribing, and I'll see you in the next video.